Hello, guys. I hope everyone is doing well. I hope you had a good day and um, the looming closeness of prelims and final exams is not killing you guys. My name is Rutendo. I'm just going to share my screen just for the introduction so you can see what I look like and know that there is a real person and not a robot at the end of the screen. My name is Rutendo. I'm a tutor here at the Learning Space. And today we're going to be going through a past paper question that you guys should be familiar with, or you should be able to do most of the questions here. So it's a paper one question. We're going to be going through some algebra, some number patterns, and some functions. And we're going to try and finish all of those. Okay, cool. Let us begin. So this first question is a nice simple one. You guys should be able to do it very, very easily. Can you guys, I'm gonna give you 30 seconds because it really doesn't take that long. What do you get for x? We're asked to solve for x in this question. I'm gonna give you 30 seconds. You don't even need the 2 minutes that they give you. You literally just need, you don't need that much time. This is just a standard question. This is so usually in your paper ones, the first thing that you're going to see is going to be algebra, and it's going to be very basic algebra questions, and then they'll get harder and harder as you go down the question. Okay, I see a lot of responses, which is very good. Okay, so first question is normally in grade 10 and 11, you are taught that if you have two brackets and they're equal to zero, then you can set one bracket equal to zero and the other bracket equal to zero, right? In this case, we have x minus 3 equal to 0. And so this bracket is essentially just x, and then the other one is x minus 3. So you can say x is equal to 0, or x is equals to, or x minus 3 equals 0. And so your two answers, when we move the 3 to the other side, it'll be a positive now. So your two answers are x equals 0 and x equals 3. Okay, so that one is nice and simple, not too bad. Okay, next question says, solve for x correct to two decimal places. Two decimal places is your hint that you're going to be using quadratic formula, right? And quadratic formula says if I have, if I'm looking for the two, let's say I have my equation um, as ax squared plus bx plus c equals 0. If I want my two values for x, I have an a, I have a b, I have a c. You can remember it as minus b plus minus square root of b squared minus 4ac, and that'll be over 2a, right? And so you're just substituting in the values for A, B, and C in each of these cases. But in the question that we're given, we don't have A, B, and C in the standard form, so we have to make it that way. We are given 2x squared plus 1 equals to 4x. So we have to change that into a version that we know, and to do that, we just need to move the 4x to the other side, right? So we'll have 2x squared. I'm going to put it as minus 4x plus 1 is equal to 0. And now we know that this is our A, this is our B, the whole of this thing. So the minus 4 is our B, and this is our C. Right. And so we can put it into our quadratic formula. We can say x is equals to plus minus square root, plus minus b, which is minus 4. Oh, sorry. X is equals to minus b, so minus 4, plus minus square root of minus 4 squared minus 4 times a, which is 2, and c, which is 1, all over 2 times 2, right? This, if we simplify this, we'll get 4 plus minus square root of 16 minus 8 all over 4, right? And so you can get your two x values by saying the one of them is going to have a 4 plus square root of 8 over 4, and the other one is going to be x is equals to 4 minus the square root of 8 over 4, right? And your two values that you get for x are x is equal to 1.71, 1.71, and the other value will be x is equals to 0.29. Perfect. I see a lot of you got that right. So both of those would be correct. Okay. And they said to two decimal places. So you want two decimal places there and there. Okay. Then we have this inequality over here. Now I like to treat inequalities. We have x squared minus 2x minus 3 is greater than 0. The way that you can think about this, if inequalities kind of trick you up, is think of this just as a normal equal sign, right? You can treat it as a normal equal sign and do what you normally do with an equal sign. But if you ever have to divide through by a negative number, right? So if you have to divide by a negative number at any point, then you have to switch the direction of the sign. So if it was a greater than sign, if you divide by a negative, then you have to put it as a less than sign. Okay, but let's see. If this was an equals, right, like a phantom equals, we know that we are going to have a trinomial on this side. So we're going to try and make two brackets, right, equal to 0. But here it's just going to be greater than 0. And here our two brackets, the factors of 3 and 1, right? And so I'm trying to get to minus 2. Oh, my bad. Hold on. Let me just go back. There you go. The factors are 3 and 1, and we're trying to get to minus 2. So we can say minus 3 plus 1 to get us to minus 2. So x minus 3, x plus 1, right? That will give us minus 2. And then from here, we can get two values for x. We get x is equals to 3 or x is equals to minus 1. Now, these are not our values. We are looking for the range for which this is true. We're looking for the x values or the range of x values that this is true. So we have actually found our critical values. These two are critical values, not the actual values for or not the actual answer for this question. And so we need to draw a timeline to see if we can test out where this relationship is true. So some people use a parabola, right? If you were to draw this parabola, this is a happy parabola, right? Because our a is positive, our intercept is at minus 3, and we know that these are our x-intercepts. What we've just found here is we made y equals 0 essentially, and then we found two y-intercepts. Our first y-intercept, x-intercept is minus 1, and our second intercept is 3. And we are looking for, what are we looking for? We're looking for where this parabola is greater than 0. So where the y values for this parabola are positive, right? And we can find that that is in this region where if this is our 0 over here, right? Our graph is positive in here and it's positive over here, right? And so we can say, you can look at it in the parabola form, right? And you can say that it's all the values before here. So all the values going in this direction because this keeps going in that direction. So all the values before minus 1. So when x is an element from negative infinity to minus 1, union after 3, everything after 3, your graph is above the x-axis. So it'll be x is an element from 3 to infinity. And because it didn't say included here, it just says greater than. We're going to use round brackets. But some people prefer to use a timeline, right? So if you use a timeline, then you'll have minus 1 over here and you'll have 3 over here, right? And in your timeline, you're going to test values of x with your original equation. So let's say our original equation was x squared minus 2x minus 3. We want to find places where this is greater than 1, or we want to find it where values where this is positive, right? So let's look at in this region here, in region 1. In region 1, let's try minus 2, right? So when x is equal to minus 2, let's see what we get. So minus 2 squared minus 2 times minus 2 minus 3. This gives me 4 minus, oh, that will be plus 4 minus 3. So this gives us a positive number. This gives us positive 5, I think. Yeah, positive 5. So we know that in this region, before -1, all my values are going to be positive, right? Let's try in this second region. So in region 2, let's say x is equal to 1, right? Between -1 and 3. So you pick a number between -1 and 3, and let's choose x equals 1, and we'll say 1 squared minus 2 times 1 minus 3. So we're just testing, is it going to be a positive or negative? If we put in a value for x between this range, will it give us a positive or negative number? And let's see, this gives us 1 minus 2 minus 3. This gives me a negative number. So I know that in this region, I'm going to get a negative number. And then let's try in region 3. Or let's call it A, I think B and C. A, B, and C. In region C, let's try out 4. X is equals to 4. So when x is equals to 4, because that's greater than 3, we will have 4 squared minus 2 times 4 minus 3, right? That'll give me 16 minus 8 minus 3. That's going to give me a positive number, so that'll be a positive value. And so you can see that our positive values in terms of our number line lie before -1, right? And after 3, right? From negative infinity, here's negative infinity, here's positive infinity. So from negative infinity up until 1, these will all be positive. Between -1 and 3, these are going to be negative. And between 3 and infinity is going to be positive again. We were looking for where this expression here was greater than 0, which means we were looking for where it was positive. And when we put in different values for x, we were able to find that before -1, so from negative infinity to 1, and after 3. You can also write this as when x is less than -1 and when x is greater than 3. So both of those work perfectly. Okay. And then our next question is kind of an exponent type question. Here we've got some exponents that we want to find x again. We're trying to solve for x. And I can see that we have 2's and x's lying around. So what I'm going to try and do is I'm going to try and get a k, right? Because I want to be able to say let something equals k, right? And then we can find, it's probably going to be a nicer trinomial in that way. We're going to end up with something like a k squared plus bk plus c. Right. Now, this C doesn't have to have the K, so we don't have to find something common between all of them, just these first two terms, which I think is going to be these first two terms over here. Okay. So I know that I can write this 2 to the power of 2x. I can write it as 2, but and if you can see, I want something squared. I want my k to be something that I'll end up squaring later. So I'm going to make this 2 to the 2x. I'm going to make it 2 to the x and then put another 2 on the outside, right? Because that means that this is the same thing. We know from exponents, if I have a to the a b and then I have x here, right? This will be a to the bx. Like the exponents get multiplied by each other. Okay. So what I'm trying to do, I've just separated, I've worked backwards. I had this already, I've converted to this. By taking this 2 to the 2x, I separated it into x to the exponent 2, right? Then I'm going to separate this 2 to the x plus 2. So we know that if I have the same base, so a times a, and let's say I have x and y, I can add these exponents, right? So it'll be a to the x plus y, right? That's what my exponent law says. I want to work backwards. I currently have 2 to the x plus 2. This can be written as 2 to the x times 2 to the 2, right? So I'm going to say this minus 2 to the x times 2 to the 2 minus 32 equals 0. And then I'm going to let 2 to the x equals k, right? And so I can rewrite this whole thing as k squared minus this 2 to the 2. I can write it as k times 4 minus 32 equals 0. I'm going to write it as a nicer exponent, nicer trinomial. It'll be k squared minus 4k minus 32 equal 0. Okay, now I need to find two things that go into 32 that I can make minus 4 with, and 8 and 4 will allow me to do that, right? So if I say minus 8 plus 4, that'll give me a nice it'll give me minus 4, right? So let me just make some space on the side here. Okay, so now that means that I can make two brackets, k minus 8 and k plus 4, right? And this is equal to 0. So this is where we started. We just broke it down like that. And now I can say k minus 8 is equal to 0, or k plus 4 equal to 0. And so k is either equal to 8 or k is equal to minus 4, right? Now we had substituted something in for k. So we can't leave our answer here. They want the answer for x, not for k. So we need to put this 2x back into the place of k. And so I can say 2 to the power of x is equals to 8, or 2 to the power of x is equals to minus 4. Now, with this second one, there is no exponent I could ever have that could make something negative, right? Even a negative exponent. If this is 2 to the minus 3, that will just give me 1 over 2 to the 3, right? Because it's a negative exponent, I can bring it down. But it'll never give me a negative number. I can never put something to the power of something and get a negative number. And so this one already, the second option, is going to be no solution. It's not going to be able to work. You can say no solution, or 2x cannot equal to minus 4, right? But we can definitely do this one, because we know that I can make this 8 2 to the x. I can write it as 2 to the 3. And if I have 2 to the something is equals to 2 to the 3, I can drop the bases, and I know that x is going to be equal to 3. Okay, so the only answer would be x is equal to 3. Okay, cool. Then, so if you guys were wondering where the marks are allocated in this question, you get marks for breaking this down into the different exponents, right? The exponent laws. So you get a mark there. You get a mark you also get a mark for writing x 2 to the power of x equals k. So if you're using k substitution, that's fine. You get a mark for factorizing here. You get a mark for, so this is out of 5 marks, right? You get a mark for finding out that this one is a no solution, and you get a mark for this one. Okay, they've already tested if you can do a trinomial before, so they know that you know how to do that, or you don't know how to do that based on the previous questions. Okay, so for this no solution part, right, you have 2 to the x is equals to minus 4, right? There's no exponent, there's no power that you could put anything to. So 2 to the 2, that's 2 times 2, right? That'll be 4. 2 to the minus 2 is just, if we want to make this exponent positive, I have to bring it down 2 to the minus 2 to the 2, sorry, it becomes 2 to the 2. So it'll be 1 over 2 times 2, which is 1 over 4, right? There is no exponent that will take this 2 and make it into a negative number. This number is currently positive. There's no exponent that will ever get you to a negative number, right? So no matter how much you try and put it, what number you try, no matter how big the number is, it'll only give you positive numbers. You can never get a negative number by having an exponent of something, right? You can get, let's say if it was minus 2 to the power of, let's say 3 is equals to minus 8. That's true because that's minus 2 times minus 2 times minus 2. So you can get an exponent of a negative number giving you a negative number. That's fine, right? But you can't go from a positive to a negative. You can't go from a positive to a negative, and the exponent is what is causing it to become negative. Your exponent can never make anything negative, right? The number itself has to be negative by itself before, if it's gonna be, a negative in the answer. But an exponent can never make anything negative. Okay. Okay, cool. And then we have this question over here. So we have a root. Now, whenever you see a root, I want you to already tell yourself that I'm gonna have to check my answer later, right? All the answers that I get from a root type of question, I have to check because at some point we're going to have to square this root, and this sometimes introduces some answers that are not true. Okay, so you have to check these answers later. So that's just a mental note that you make for yourself to say, I need to check this when I'm done. Okay, but first order of business, I know that I need to square root at some point. I need to square the square root, but it has to be by itself on the one side. So I need to get rid of this x or move the x to the other side. Is equals to 2. I'm going to move the x to the other side. It's going to be 2 plus x, right? Now you can square both sides. Square both sides, and you will get minus 2x minus 4, right? Because now this root is cancelled there, and then this gives you equals to x, oh sorry, 2 plus x and 2 plus x, because it's just now two of those. 2 plus x and 2 plus x, right? Okay, so now I'll have minus 2x minus 4 is equals to, if I expand this, I'm going to get a 4 plus 2x plus 2x plus x squared, right? And so I'll have minus 2x minus 4 is equals to 4 plus 4x plus x squared. And then I'm going to bring everything to this side, right? So I'll have 0 is equals to 4 plus 4x plus x squared, and then plus 2x. Sorry, guys. I do not have my charger on. Let me just plug my charger back in. Sorry about that, guys. So we moved the, oh, sorry, this is a plus. Yes, 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 yes. Sorry, guys, plus, plus, plus. So it'll be, here it'll be 2x minus 4, right? And so then we have 0 is equals to 4 minus 4 cancels out. 4x plus 2x is 6x, so it'll be x squared plus 6x. Now, this is not a trinomial, but we can get a common factor out. So 0 is equals to common factor x, and then x plus 6, right? And so we can say x is equal to 0, or x plus 6 is equal to 0. So x is equals to minus 6. Okay. And then we're done. Oh, but we said we need to check our answers before we're finished. So we check our answer by putting it into the original one. So let's check x equals 0. we have the square root of minus 2, 0 plus 4, minus 0. This needs to be equal to 2 because that's what it was supposed to be, right? So this needs to be equal to 2. Let's see if that's the case. So I have minus 2 times 0 here is going to be 0 plus 4. The square root of that minus 0. Let's see, this gives me 4 square root of 0. Square root of 0 is equals to 2. So that checks out. That one works. So x equals 0 is one of the answers. Let's try x equals 6. I'll try square root of, or square x equals minus 6. Square root of minus 2 times minus 6 plus 4 minus 6. This needs to give us 2. Let's see if that works. I'll have square root of 12 plus 4 plus 6. 12 plus 4, square root of 12 plus 4, square root of 16 plus 6. This gives me 4 plus 6, which is equal to 10. This is not equal to 2. So x is not equal to minus 6. Right. So x is equals to not equals to minus 6, or this one is not applicable, or no solution. Those all work. That's such a weird spelling for no solution. Right. So this one wouldn't work. The x is equals to minus 6 would not work because ends up giving us this whole thing is equal to 10 instead of 2. Okay, so you always have to check whenever you have a squaring of both sides, you always have to check that your answer is actually true because you can't just go with it. This introduces some extra answers into there. Okay, okay. Then we have a wonderful simultaneous equation, which you are going to have to do. There's always a simultaneous equation. By fire by force, there will always be a simultaneous equation. So we are going to try this one. I don't know about you, but I was taught to make, there's two types of simultaneous. There's substitution and then there's elimination. I'm going to do the substitution one now. Um, yeah, so for the substitution, I always label my my equations something. So we have this one is 1 and this is equation 2. And so my first step is to look at both of these and say which variable, x or y, would be easier to isolate or get by itself and in which equation. I'm looking at equation 1, and I feel like you can get y by itself pretty easily in equation 1, right? So I'm going to say find y in equation 1. Now this one is just, you don't have to really write the step, but I like to write it out to show what I'm doing. So I have 2x plus y is equals to 3, right? I'm going to move the 2x to the other side. So y is equals to 3 minus 2x, right? This line you have to write. So sub, okay, yes. And now I'm going to make this equation 3, right? Sub 3 into equation 2. So I'm going to substitute this into the other equation that I had here, right? And wherever, that means that wherever I see y in that equation 2, I'm going to put in 3 minus 2x. So I'm going to have 3 minus 2x squared plus x times 3 minus 2x is equal to 2. Okay, now the reason that this works is that now we only have x's in this equation, right? Now we can solve for x because that's the only thing. We couldn't solve for x or y here because we were missing both x and y in both of these equations. But now we can solve for x in the second one so nicely because we can just expand out and find what we are missing. Okay, so if I expand out this first bracket, I'll get 9 minus 12x plus 4x squared. And then if I multiply in this x, I'm going to get plus 3x minus 2x squared. And I'm going to bring this 2 to the other side. So minus 2 equal 0. Okay. And so then I've got like terms, so this 9 and this minus 2, and we have this 12x and this 3x and this 4x squared and this minus 2x squared, right? And so now we are going to have to, what are we going to have to do? Now we're going to group all of our like terms and bring everything together. You'll see that we have, let's start with the x squareds. 4x squared minus 2x squared, that gives me 2x squared. And then that'll be minus 12 minus 12 plus 3, it'll be minus 9x. And then 9 minus 2, that's going to be plus 7 equal 0, right? And so I now have a trinomial. I have to try and get something that is a, I have to look at 7. What are the multiples of 7 or factors of 7? I know I can use 7 and 1. And because there's a number in front of this x, I also have to use 2 and 1 there to get to minus 9. So I like to use the cross multiplication method. So I'll say 2 and 1 can go with 7 and 1, right? And then you cross multiply, so that will give you 7, that will give you 2, right? And so I'm trying to get to minus 9. I have to say minus 7 minus 2. So here, these are the x's, and those are just the constant. So my two brackets will be, from here, I'll have 2x minus 7, and then the other one will be x minus 1, or 1x minus 1 equal to 0. And so my two equations are going to be 2x minus 7 equals 0, or x minus 1 equals 0. So 2x is equals to 7, so x is equals to 7 over 2, right? Or x is equal to 1. Now, these are just my x values. I found my x values now. I need to find my y values. So here we're given that we've just found that x is equals to 7 over 2, or x is equals to 1, right? And so that means that I need to find my y associated. We've made equation 3 already. That says y is equals to 3 minus 2x. So I can find my y values for each of these. So if I want to find y when x is equals to 7 over 2, I just put in x is equals to 7 over 2, right? And I'll have 3 minus 7, which is going to give me minus 4, right? And then if my x is equals to 1, I'll have y minus 3, y equals to 3 minus 2 times 1, which is equals to, y is equals to 3 minus 2, which is equals to 1, minus 1. Oh, 1. Okay, so those are my two answers. You can write it as, yeah. So when x is equals to, 7 over 2, y is equals to minus 4, or when x is equals to 1, y is also equal to 1. Okay, the elimination one, okay, you'll have to give me some time. I did not practice that one, or I don't have the memo for that one, but let's see if we can do it. So the elimination one means that you're going to try and get, so you have two equations, 2x plus y is equals to 3, and the other equation is y squared plus xy is equals to 2. You have to try and get either x or y to be identical in both of these expressions, right? And to do that, you have to, I don't know if it works in this one, let's check. You have to multiply through or divide through by something everywhere. Right. So let's say I'm going to multiply everything through by, I'm going to multiply everything through here by y. I don't know if this is going to work. So if I multiply this by y, multiply this by y, multiply this by y, it doesn't really change anything in my expression. Now everything just has a y. So it'll be 2xy plus y squared is equals to 3. Yeah, I don't know if this is going to work. Maybe I'll try it the other way around, right? And so now you can subtract one equation from the other. So let's subtract them like this, like how they are now. So y squared plus xy is equals to 2 minus, let me just put y squared plus 2xy is equals to 3. So if I subtract y squared minus y squared, that those will cancel out. X minus xy minus 2xy gives me minus xy is equals to 2 minus 3, which is going to be minus 1. Okay, but now we still live with xy. Let me try another way. Okay, let's say we have again our two equations. We have two, oh, what is it's 2xy, 2x plus y is equals to 3, or y squared plus xy. Um, yes, it's equal to, yes, sorry about that. You are correct. So maybe it'll still work, okay? So she's saying, someone is saying, I don't know who that is, but they're saying that I made a mistake here. I didn't put a 3y. Yes. Okay. Okay. I don't know if that helps us, but let's see. Okay, yeah, so that still gives us minus xy is equals to, yeah, 2 minus 3y. Now you have a 2 somewhere in there, and you don't have any way to get rid of it. Yeah. Okay, let's see. Let's try 2x plus y is equals to 3, and y squared plus xy minus is equals to 2, right? Let's divide through, yeah, so this one may not work. Let's divide through here. So the reason why I was multiplying by y is for the elimination method. You have to try and get either, sorry, you're trying to get x, you're trying to get x or y in both of these to be the same, in both of these equations to be the same, right? I don't think it's going to work because we have an xy here, and so it'll never cancel out. Yeah, I don't think it'll ever work. You're trying to get so that when you subtract here, let's say if this was just that, then maybe it would be you'd be able to get a 0 for xy. These two could cancel out or something like that. So you're essentially trying to cancel out one variable from both equations when you're subtracting them. But I don't think this one works because of that xy. Let's just try this one last thing. Let's say I want to get both of them to have just one y. So I can divide through by y for everything, right? But now you have a 2 over y. Yeah, I don't think it's gonna work. So let's see. Here you'll have 2x plus y is equals to 3. And so you'll have here y, because you'll have cancelled out there, plus that will cancel out there, x, oh, sorry, yeah, x, and then is equals to 2 over y. Yeah, you still have this y that will be left in that equation. So even if you subtract these two, right? If you subtract these two, your y's will cancel out, yes, but then you'll have 2x minus x, that'll just give you x. Then you have 3 minus 2y. You still have x and y in that term as well. So you wouldn't be able to, yeah, xy keeps coming back. So you can't use elimination when you have a term that has both x and y, that has both variables in it. You won't be able to get rid of. one of the variables, like they'll both keep coming back. Okay, so it's best to do it using the substitution method to try and solve that. If you don't know it, then I think you should practice so that in the event that it does come up, you know what you're doing. Okay, so we tried to do the process of elimination, but it doesn't work because both of these equations, no matter what we try to do to get one of the variables to cancel out, the other variable was still in the equation that we had at the end after we subtracted. So you can't use elimination when you have both of the variables being multiplied by each other in one of the equation. Elimination is not bad. It's actually quite easy, but yeah, it wouldn't work here. Okay. And then we have this one, right? So this is the last one in your algebra section. And usually this one is a little bit tricky because they really want to test, do you know algebra or do you know algebra? Right? And so this one is saying, consider the product. Product means multiply, right? So consider the product multiplication of these three, right? Where each factor or each bracket is in the form of 1 plus 1 over n, right? And they want to say determine all the values of n for which the product will be an integer value. Okay, so they want to know an integer is a whole number, right? So it's like 1 or 2 or 3 or 4. So what values of n, if I kept going up and up and up? So let's say this is, so because n starts at 2, this is n is to 2 gives me 1 plus 1 over 2. If you put this in your calculator, you'll get 3 over 2. If you put in n equals 3, it'll increase to 1 plus 1 over 2 and 1 plus 1 over 3. If you put this in your calculator, you'll get, this will be 3 over 2 multiplied by, this will be 3 over 2 multiplied by 4 over 3, right? They want to know, like, for what values of n, so if this is 3, then it goes up to 3. This is 2, it goes up to 2. So n equals 4 would be 1 plus 1 over 2, 1 plus 1 over 3, 1 plus 1 over 4, right? So this will give me 2 over 3 over 2, 4 over 3, 5 over 4, right? We want to know what n value would give me an integer. So either 1, 2, 3, 4, a whole number. So it can't be a decimal. It can't be like 7 over 2 because that would give me 3 comma 5, right? But it can also be a negative number. So it could be minus 1, minus 2, minus 3. We want to know what values of n would give me whole numbers or integers, right? When we multiply all the brackets with each other. N has to be greater than or equal to 2. Let's see, what does this first one give us? This first one, when n equals to 2, we get 3 over 2, and that's not an integer. That's going to give us 1.5, right? But this one gives us, can you see that I can cancel out these threes that are here, right? I can cancel out those threes, and I'll be left with 4 over 2, and that'll give me 2. 4 divided by 2 is just 2, right? So that gives me an integer. So when we know that when n equals to 3, I get an integer. Let's see, when n equals to 4, um, the 3's cancel out here and the 4's cancel out here. But I'm left with 5 over 2, which is 2 comma 5, which is not an integer, right? Okay, but can you see the pattern? If n equals to 4, all the numbers at the bottom are just going down, are just going up by 1, right? And then the numbers at the top are also going up by 1, but they start at 3, 4, 5, right? So n equals to 5, we don't even have to write it out. I can tell you now, it's going to be, since it goes 5, it's going to be 4, it's going to be 3, it's going to be 2. right? And then this is going to be 6, this is going to be 5, this is going to be 4, this is going to be 3. These are the same as, these are all the same as these ones. I've just added now when n equals to 5. Okay, and you can see that this then cancels out. That cancels out with that, that cancels out with that, that cancels out with that. And now I get 6 over 2, which is 3. Ah, okay. So in n equals to 5, I get a whole number. So I'm seeing a pattern that when it's an even number, we get a decimal or we get something that's not an integer. But when it's an odd number, when n equals to something that's odd, right, we then get, then we were asking for all of them. So we're not just asking for one, we're asking for all of them. Our n is going to be our, sorry, the product of all of them is going to be an integer, it's going to be a whole number. Let's see, let's test our theory with, let's say n equals 7, right? Let's skip one. Because n is 7, I'm predicting that it's going to give me a whole number. And we said we don't really have to write down the 1 plus whatever. We know it's going to start at 2, 3, 4, 5, 6, and 7. Right, and then the top is just one more than the bottom. So 8, 7, 6, 5, 4, 3. I hope I haven't missed any. Okay. And now we can see all the things that cancel out, cancel, 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 and cancel, cancel. That gives us 8 over 2, which is 4, which is also a integer. It's a whole number, right? And so we can say, we can conclude by saying that therefore, therefore, that's crazy. Therefore, the product will be an integer, an integer. So the product, the multiple of all of these will be an integer when n is an odd number. Okay, but it has to be an odd number greater than 2. Okay, if you want to write it out, you can write n as an element of 3, 5, 7, dot, 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 like that, right? So this one is a little bit tricky, but it's only for 3 marks. So this one, if you get stuck here, you can, if you're spending more than 3 minutes on there, then you need to stop, maybe take a break from it, come back to it later when you try and understand a little bit more. But it's not worth a lot of marks. It's like one of the trickier questions. So if you get stuck, then try it, attempt it at first. If you can't do it after 3 minutes, then you can move over to the next question. Okay. Okay, cool. Then we have, oh no, sorry, I was supposed to erase all of these. My bad. Let me try and erase it before you guys can see it. So, here we are given this. I want you guys to try this while I erase the rest of my paper. So you're given that the first term in an arithmetic series is 7. The common difference in the series is 5, and the series counts 20 terms. Calculate the sum of the series. Okay, so someone asked, um, how do you, what are the tricks that we have for the previous question? So I'm just going to go up to this previous question. I would say the trick here is they want you to notice a pattern. They want you to notice something that's happening for the different n values, right? They are asking for what are the values of n. So when n equals 7, the products go up to something over 7, right? What are the values of n that will That will mean that when you multiply all the the brackets together, you'll get an integer value, or a value that's not a decimal or a fraction, right? A value that's not a decimal, basically, when you simplify it. They want you to notice the pattern that when n equals to 2, you get a decimal. When n equals to 3, you get a whole number. When n equals to 4, you get a decimal. When n equals 5, you get a whole number. They want you to see that as the n values change, you get different values when you multiply all the brackets together. And they just want you to realize that when n is an odd number, so when n equals 3, you're going to get a whole number. But when n equals 4 or an even number, you're going to get a decimal. That's basically what they want you to understand. Okay. The trick is it's always a pattern. They want you to see kind of a pattern in whatever the expression that they've given you here is, right? And so always look for a pattern. You'll see in all of the past papers that you have, that last question is always kind of like a weird question. It'll always be either you have to make an equation out of a number sentence, or they want you to notice a pattern in something that they've given you. Okay. Okay, so then we move on to this one. They say the first term of an arithmetic series is 7. The common difference of this series is 5, and the series contains 20 terms. So on your formula sheet, you get all the formulas that you need for a question like this. So I'm going to give you the sum for a arithmetic sequence. So Sn is equals to n over 2, 2a plus n minus 1 times d. That's the sum of a certain number of terms of an arithmetic sequence. I want you to find the sum of this series. I'm going to give you 1 minute. Can you please find the sum of the series for me? What is the sum of this series? Okay, I'm seeing some answers pop up. Okay, I'm just looking for the sum for the series. What is it gonna be? Okay, so we are told a bunch of information that can help us. So we've got, they told us that it's 20 terms, so 20 over 2 is equals to 2. The first term is going to be 7, and then plus 20 minus 1 times the difference, which they told us is 5, right? So you just solve this normally. This is going to be 10 multiplied by 14 plus 20 minus 1 is 19 times 5. You do the 19 times 5 first. You should get 1090. So that is the sum of this whole series. Okay. Then we are asked, okay, let me just move this a little bit further up and move that question a little bit down so that you can see it as well. So then you're asked the first term, okay, sorry. Then they say the original arithmetic sequence, the original arithmetic series is extended to 75. So we started with 20 of them, and now we have 75. So how many terms have been added? Can you guys tell me? How many terms were added? How many terms were added in this thing here? if we're moving from 20 to 70, 55. Perfect. Okay, the sum of these 75 terms is 14,400. So if I take the sum of all 75 terms, I get 14,400. Using sigma notation, which is that, write down an equation for the sum of the terms added to the original series. Right. So they're asking, we added these 55 terms to the sequence. We want to write in sigma notation what those terms are. Right. So we found that the sum of the first 20 terms was 1090, 1090. Right. This was the first 20 terms. They started at term 1 to term 20. Right. Then we added a certain number of terms that allowed us to we added 55 terms, and now we have 75 terms, sorry. And when we add all of the 75 terms that we have, we now have this big number right there. Okay, so I want to represent the numbers that we added in terms of sigma notation. So sigma notation means that we are going from 75, right? We are starting not at, let's say this was n. We're not starting at n equals 1 because we just want to show the terms that were added to this 20, right? So we're not going to start at 1. And I want to ask you guys, do we start at 20 or do we start at 21? We know that there's an equation or kind of an equation that says the number of terms when we're writing in sigma notation is equals to the top number minus the bottom number is plus 1, right? Right, so we said the number of terms we add is 55. So 55 needs to be equal to the top number, which is 75, minus the bottom number, let's call that x, plus 1, right? So that's 55 is equals to 76 minus x. I'm going to move the x that side and move the 55 that side. So x is equals to 76 minus 55. And so here I should get 21. Is that going to give me 21? I hope so. Okay, that's going to give me 21. Okay, and so that means that this number over here is going to be 21. And then in this place, in the sigma, inside the sigma, I'm going to put the Tn formula for my equation, right? What is the Tn formula for my whole thing? I know Tn for an arithmetic is going to be equal to A plus n minus 1 times D. My A, I'm told already that my A is 7 plus n minus 1 times the difference is 5, right? So my Tn in this case is going to be 7 plus 5n minus 5. So it's going to be 5n plus 2. That's going to be my Tn formula, right? And so if I'm writing out my sigma notation with this in mind, my sigma notation is going to be, I'm just going to erase this part. My sigma notation is going to be a sigma is 5n plus 2. It starts at 75 and let's say n is equals to 21, right? So the question itself is asking for us to write in sigma notation the equation for the sum of the terms added to the original series. Okay, so the sum of the terms added to the original series was at 9090, so that's S of the 20, the first 20 were equal to 1090. Then we added some to get us to 75, and that gave us 4400. We want to write an equation to show the terms that were added to this initial one that got us to the 75, right? Now, if 75 terms is equals to this and 20 terms is equals to this, how much did I add from 20 to 75? Can you guys tell me how much did I add going from 75 to 20 in terms of the number between 144 to 14400 to 1090? How much was added? Yes. So 13,000, 133,000, what? 13,310 is how much was added. Our question was asking, write down the equation for the sum of the terms added to the original series. The original series was at 9. We added 1,300, 13,310 to get to this new amount, which was the 75. And to show how much was added, or to show the equation of that 13,310, we have to write it in sigma notation as starting from 21 to 75. This is how we calculated that 13,000. It's the sum of all the terms from 21 to 75 using this formula to sum them up. Okay. So I know sigma questions are a little bit tricky. You guys like normal number patterns where they just ask you what is the term, what is the sixth term, what term gives you 100 and all that jazz. Okay, but this is a more, you have to really understand what are you doing when you're finding sums and you're finding TN formulas and where all of those goes. So if you're looking for a sigma or the sum of something, you always put TN. If they ask you to write it out, your TN is always a thing that goes in here for your sigma. And then your sum is how, when you add all of those terms up, what do you get? Okay. Okay. Now, then they said, the sequence of first differences for a quadratic number pattern is 1, 3, 5. Right. So what does this mean? First of all, we know that we get arithmetic, we get geometric, and we get quadratic. And quadratic has a first difference and it has a second difference, right? So here they're telling us we have a quadratic number pattern and they tell us what the second difference is. They've told us that the first difference, sorry. They told us that the first difference is 1, 3, and 5. So let me just give you an example here. So if you had a number pattern, okay, let me think. Um, let's say you had 3, so just on this side, 3, 5, 9, and 15, right? The first differences here would be 2, then this would be 4, then this would be 8, right? But when you look at these, sorry, this is 6. This would be 6. This would be 6. You get 2 as the second difference and 2 as the second difference, right? And then to find the equation for this number pattern, you'd say 2a is equals to this first one, 3a plus b is equals to this one, and a plus b plus c is equals to this one, right? In our case, they have only given us this. They've given us the first difference for that pattern. So if we were to write this, we don't know what these are, the original pattern. We can say x, y, z, and w. We don't know what those are. We don't have to solve for them, so it's okay. We just know that the difference between the first two is 1, the difference between the second two is 3, and the difference between the third is 5, right? Okay, right? Then they tell us, so we can find the difference between these two. This is 2 and this is 2. They ask if T99 of this quadratic pattern, so we know that this is T1, T2, T3, and T4, and going dot, dot, dot. So they're saying T99, T99 here is 9632. What is the value of T98? So the term before it, T98. What is the value of that term? Now, we don't know what that term is. We don't even know what the first few numbers of that quadratic pattern, the first row of it, what that is equal to. But we know kind of like a good relationship between the values in our second row and the values in our first row. So if I look at this one, this would be what? I'm going to call it small t1, right? I can say that T1 is, let's make it a bit darker. So let's say this is T1. We can say T1 is between T1 and T2, which means that, can you see this T1 is between T1 and T2, right? Small t1 is between T1 and T2. Therefore, small t, what would be between here? Small t98 is between T98 and T99, right? So if I can find what is the difference between these two numbers, if I can find small t98, I can just subtract whatever this number is from this 9,632 and get the number before it, right? So if I had, let's say in this case, 3, 5, 9, and 15, right? And let's say I know that the difference between 9 and this value here is 4. That means I know that this is going to be, let's say this is 2. If I know that the difference between this 9 and the number before it is 4, I can find 9 minus 4 will give me 5. So I can find the number before that one, right? So that's what this is doing. We're saying because we know that this T1 lies between the first and second term, if we can find T98, right, what this number is, we can just subtract it from this 9,632, go backwards, and get what this T98 is, right? Okay, so let's try and find that T98. We know that we can find that Tn is equals to our sequence is 1, 3, 5, dot, dot, dot. We know it's a linear pattern, so we know it's going to be A plus 1 n minus 1 times D. A is 1 plus n minus 1. We're looking for T98. So we can actually put 98 there already, minus 1. And my difference here is 2 each time. So 2, right? And so this gives me, if I am to try, if I put this all in my calculator, I'll get 195. So I'm telling you that the difference, so I have T98, I have T99. I know that this is 9632. And I can tell you that to get from 98 to 92 to 99, I had to add 195. Can you tell me what this T98 is going to be? I see a few people have already gotten it. You're just going to say this 9632 minus 195, right? And that should give you 9437. Okay. I thought of another way to do this, which I'll show you, but it's actually the next question, right? I thought if we just find What did I think? Because we're told, or we're not told anything about the first bit, we're told the first differences. Um, there was another way I thought about this, man. Oh, I forgot. I forgot. Oh no, we couldn't do it here because we're not told the equation. We're not told anything else. But yeah, this is how you would do it because you're not told the first differences. You're not told the first terms or anything like that. You would have to. Oh yes, yes. I thought about it like this. Can I tell you? But it actually gives it away for the next question. So this is the first way to do it, right? I thought about it like this. So this was what the memo had. That what I just did now is what the memo had. I thought about it as okay, we have our first differences. So we have, let's say, X, Y, Z, and W. We know that this is 1, 3, and 5, 1, 3, and 5. And we know that our second differences are 2 and 2. We also are given that T99 is equals to 9632. Right. I thought we could find the equation with just this information. I don't think we need any more information than this. And to do that, we're going to try and find the equation of a quadratic pattern. So we'd say 2a is equals to this, 3a plus b is equals to this, and then a plus b plus c would normally be equal to this first term, but we don't know what that is. So we are going to have to use this extra piece of information to find that. But let's see. So we know that the equation for a quadratic number pattern is an squared plus bn plus c. So in this case, we have 2a is equals to 2, so a would be equal to 1. And then 3a plus b is equals to 1, so 3 times 1 plus b is equals to 1, and so b is equals to minus 2. So at the moment, if we substitute in, we have tn is equals to a, which is 1. So I'm just going to put 1n squared plus b, which is minus 2n plus c. We are missing this c value, right? And I think we can get it by substituting in this point. We know that at this point, n is equals to 99, and we know the value of it at that point, right? So we can say 9632 is equals to n is 99 squared plus minus 2 times 99 plus c. Now all we're missing is c. Okay, if you do this in your calculator, you should get c is equals to 29, right? Which means that your Tn formula is going to be Tn is equals to n squared minus 2n plus 29. And then you could put in just T98. So you put 98 squared minus 2 times 98 plus 29. And that should give you the same answer as before, which was our 9437. Let me just check that before I give you guys false information. Okay, so we have 98 squared minus 2 times 98 plus 29. Yeah, plus 29. It gives you the same answer, it gives you 9437. Right. The second method is longer, but it's something that you would be familiar with doing because you've kind of done things where you are missing maybe a value, or you need to find the n of something, or this one feels, I feel like, more familiar to what you guys have done before than trying to guess, okay, like if T1 is between this and this, then T98 is between this and this. It's a bit longer, right? But I feel like it's a more solid way. And now you have the equation that you need for any further questions. Okay. Um, okay. So this method comes up again, right? Because they then ask you, it is further given that the third term of the quadratic sequence, so T3, is 32. Determine the general term. Now, we didn't really need this information because before, in our previous question, we just used the fact that T99 was equals to 9,300 and what? 9,632, right? We used this information to get our Tn, but let's just do it again, right? So we're given X, Y. So this is what I meant by in the previous question, I didn't want to use the second method because they end up asking you for the formula anyway. But you can just use the fact that this information that they give you to reprove the formula. So you don't have to stray away from it. You can just reuse it again. Okay. We know the difference between this is 1, 3, and 5. And this is the second difference would be 2 and 2, right? We're looking for the Tn formula, which is in the form of an squared plus bn plus c, right? And so we have 2a is equals to this, 3a plus b is equals to this, and then a plus b plus c is equals to this. We don't know what our x is, so we're probably not going to use this last formula. But to find a, again, we'd say 2a is equals to 2, and so a is equals to 1. To find out b, 3a plus b is equals to 1, and so 3 times 1 plus b is equals to 1, and again, b would be equal to minus 2. And then now we can substitute into our Tn formula. So at the moment, we have Tn is equals to 1 n squared plus minus 2n plus c. We're missing our c, so that means that we are going to substitute in this thing that we have that we've been given. So we know that when n equals to 3, Tn is equals to 32. So again, 32 is equals to n is equals to 3 squared plus, plus minus 2 times 3 plus c. And this again should give you a c of 29. Okay. Okay. And then, so now we have Tn is equals to n squared minus 2n plus 29, which is the same formula that we had before in this case when we solved it using the 99th term that we were given. Oh, sorry, this is 90. Oh, yeah. Using the 99th term that you were given. So both of the terms that you were given could have worked. Okay. Okay. Cool. Coolio. Okay. Then, or, or if you were feeling very smart, they told you that this third term, Z, is 32, which means that you could have eventually found the first term. So 32 minus 3 would have given you, 32 minus 3 would have given you 29. And then 29 minus 1, you would have given you 28. And then you could have used that to get your C. So you could have said A, which is 1, plus B, which is minus 2, plus C would give you 28, right? So this would give you minus 1 plus C is equals to 28. And so C is equals to 29. Okay, so even if you didn't know how to do this, right, at all, in the previous question or here, you could have found, they told you something close enough that you could have used two methods to do it. Okay. Okay. Perfecto. Now, the interesting question. So here we're given a circle with a radius of 6 centimeters is drawn. A second smaller circle is drawn through the center of the first circle. So the first circle is actually this one, the big one. That's the circle, the first circle. And they tell us that that has a radius of 6 centimeters. So 6 centimeters is from the center to the end. So this would be 6 centimeters, right? Or like this whole thing would be 6 centimeters. Then they said a second smaller circle is drawn through the center of the first circle and touches the first circle internally. The third circle is smaller, is drawn through the center, and da, 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 da. So if it's drawn through the center, that means that it's gonna have half the full thing. The diameter is gonna be 6 for that second circle, which means that its radius is gonna be what? It's gonna be 3, right? 3 centimeters. What is the radius of the third circle gonna be? Of the smaller one? What's the radius of this third circle gonna be? Of the small one? What do you guys think? We're told that the big circle is the radius is 6 centimeters. The second circle is drawn through the center of the first circle. So the edge of it touches the edge, which means that the diameter of it is going to be 6, right? And this third circle is drawn also in the center of that 6 centimeter one. So its diameter is going to be 3. You guys are correct. The radius would be 3 divided by 2, which is going to be 1.5 centimeters. Okay, so that's the radius for our third circle. Then they ask, calculate the sum of the areas of the first 10 circles. Yo. So we already know that this is probably a number pattern of some sort, right? Because they're asking for the 10th circle, which is not somewhere we are close to. But they're asking for the sum, so sum of the areas. So we have to make a pattern with the areas, and we want to find the sum of the first 10 circles. Okay, so let's first find the areas and see what we're working with. So let's see the area. We know area is pi r squared, right? So let's say area of 1 is equals to pi times the radius of the first circle. We said here is 6 centimeters. So 6 squared. So the area of the first circle is going to be pi times 6 squared, which is 36. If you put this in your calculator, it's just going to be 36 pi. You can leave it as 36 pi. Okay. Now the area of the second circle, which is going to have a smaller radius, right? Its radius is now going to be 3, is going to be pi times 3 squared. This is going to give me a radius, an area of 9 pi, right? Then let's see the area of the third one is going to be pi times 1.5 squared, which is going to be, this is going to give me 9 over 4 pi as my area. So if I was to list these in terms of like a pattern, I'd get 36 pi, 9 pi, 9 over 4 pi. Okay, so this is now my pattern, right? This would be my A. What kind of pattern is this? Is it a geometric or an arithmetic? Is this a geometric or an arithmetic? Perfect, right? So it's a geometric, which means that there's an R, there's a constant ratio. What is the constant ratio? How do we find the constant ratio? This is T1, T2, T3. What would the constant ratio be? You'd have to do T2 over T1, or you could do T3 over T2. So the one about ahead and then divided by the one before it. So in this case, T2 is 9 pi. In your calculator, don't try and put pi as 9 point what, 3.1415, whatever. Just put it as pi over 36 pi. What constant ratio does it give you? Or you could put 9 over 4 pi over 9 pi. So the pi's end up canceling out anyway. So what is your ratio if you put those two over each other? You get a ratio of 1 over 4 for both of them. So that's my R. So what I've done is I found the areas for all of these, right? This is my area pattern. I know what my A is, and I know that now my R is 1 over 4. So now I can find the sum of the first 10 circles, right? Because the sum for a geometric pattern, Sn, is equals to A 1 minus R to the power of n over 1 minus R. Okay, A in this case is 36 pi multiplied by 1 minus R to the power of n. We're asked for the first 10 circles. So 10 over 1 minus 1 over 4. What answer does this give you guys? What answer do you get here? What is the sum of all the areas if we put this in our calculator? I want to know what answer do you guys get? Okay, so I substituted in, oh, sorry, I forgot R at the top there. This is 1 over 4 to the power of 10. Okay, you should get 150.80 centimeters squared. Right, and this is the area. This is the sum of all the areas in the first 10 circles. So again, here you have to make the pattern. You know that it's some kind of pattern, and so you need to make the pattern so that you can use it in, the sum formula, but the sum formula needs the first value, it needs a constant difference. And to do that, you have to make the pattern, find the first term, find the constant difference, constant ratio, and then you'll be able to find the sum of all the areas. Okay, so we first started off with, okay, I was told that I wanted the sum of all the areas. So sum means I want to add up all the areas for the first 10 circles, but I don't want to find the areas for all the circles. So I'm going to make a pattern for each of them. So I found the area for the first circle, right, which was pi times 6 squared. Then I found the area for the second circle, which had a radius of 3, right? And I found that to be 9 pi. And then I found the area of the third circle, which had a radius now of 1.5, right? And that was this area. So I found my three areas, which was 36 pi, 9 pi, and 9.4 pi, 9 over 4 pi, right? I then wrote them out in terms of a pattern because I was like, this needs to be a pattern of some kind, because if they ask me for the 10th term, that means I'm supposed to be making some kind of pattern. So I wrote it out as 36 pi, 9 pi, and 9 over 4 pi, right? Then I said, okay, this kind of looks like a geometric pattern. Now let me see if it is. If it's a geometric, then I have a constant ratio. So 9 pi divided by 36 should be the same as 9 over 4 pi divided by 9 pi. And I did that. So 9 pi divided by 36 pi gave me 1 over 4. And 9 over 4 pi divided by 9 pi also gave me 1 over 4. So I know that I'm dealing with a geometric pattern, right? And so once I found that, that constant ratio is 1 over 4 that I got from here and here. And I know my first term in this case is going to be 36 pi. I know the sum formula for a geometric pattern. I know that that is Sn is equals to a 1 minus r to the power of n over 1 minus r. I know that my a now is 36 pi. 1 minus r I know is 1 over 4. And I know n is 10 because they asked for the first 10 circles. That's how many there are. So I'm looking for the 10, adding the first 10 sequences. 10 sequences, minus 1 over 4, and this gave me my 150.80 centimeters squared. Okay, so that's how we did this kind of question. The next question is similar, and I want you guys to try it. Right, so it's very similar to what we just did. We had to find the areas because they asked for the sum of the areas, right? Next question is, oh no, hold on, let me try and delete this. I didn't delete the answer before I started. Just give me 1 second. Okay. I'm going to give you guys 5 minutes. So it's similar to this one. I'm going to give you 5 minutes to try this next one. So, am I deleting the right thing? I think I am. I am. Okay. Here, let me bring my question down so that you can see it. Okay, so I have, again, the circles are still the same. I know that my first circle has a radius of 6 centimeters. So my first circle has a radius of 6 centimeters, right? 6 centimeters. Then my second circle has a radius of 3 centimeters. Then my third circle has a radius of 1.5, right? I want to know which circle has a diameter of 3 over 128. I'm going to give you guys 5 minutes for this. 5, 4, 3, 2, 1. I want to know what circle has a diameter. So these are all radiuses. So you have to first convert these to diameters. What circle has a diameter of 3 over 128? I'm going to give you guys 5 minutes to try this one. Let's see if you can get it. What circle has a diameter of 3 over 128? Very similar to what we did before. Now I'm just looking for what circle has a diameter of that. We're at 4 minutes. Which circle has a diameter of 3 over 128? They keep getting smaller and smaller and smaller, but I want to know which one ends up having a diameter of 3 over 128. Okay, we're over 5. Now we have 4 minutes left. What circle has a diameter of 3 over 128? We are 30 seconds, so you have 3 minutes and 30 seconds left. What circle has a diameter of 3/128? So before we found an expression for the area, then we found the a value, we found the constant ratio, then we were able to put it into our sum formula. But this time it's not asking for a sum, it's asking for the circle. So basically we're asking for n. What n has a diameter of 3/128? Okay, but we've got 3.5 minutes left. 2.5, sorry. 2.5 minutes. What circle is the diameter of 3/128? Okay, I can tell you that the diameter pattern, because the radius was 6, 3, and 1.5, the diameter, so this was for radius, for the diameter, your pattern is going to be 12, 6, and 3. So it's just going to be double whatever the radius is. So I'm looking for what term in the sequence has the value 3/128, essentially. Okay, we have 1.5 minutes left. Ooh, very varied answer. Let's see what we get. So many different answers. Wow, that's so interesting. Okay, now you guys just have 1 more minute left. Let's see. If your expression for diameter is 12, 6, 3, which term in this sequence will have 3/128? You have 40 seconds left. 40, 30 seconds left. Looking for the term that has the diameter of 128. We have 10. Sorry about that, guys. I'm back. Okay, so our diameter pattern is 12, 6, and 3, and dot, 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 dot. We're looking for what term is 3/128, basically, right? So we have our first term. So we know here our A is going to be 12. Our R is going to be 6/12 or 3/6, right? And both of these give me 1/2, right? So my R is 1/2. And so if I'm looking at writing out my Tn formula, Tn is equals to A to the power A times R to the power of n minus 1, right? And so A is going to be, we know my A is 12 times R, which is 1/2 to the power of n minus 1. This is my Tn formula. right? We are looking for which term? We're looking for the n value that gives us a Tn of 3 over 128. So we can write it here as 3 over 128 is equals to 12 times 1 over 3 to the power of n minus 1, right? Now what I can do here, because I can't multiply this 12 and this 1 over 3 because this has a to the power of that. So I can't do that. I can divide through by 12 on both sides. So divide by 12 and divide this whole thing by 12. And what you'll get is 1 over 512, which is equal to, oh, sorry, yes, 1 over 2. 1 over 2, and that will be equal to, again, a half to the power of n minus 1. Okay, now we know that with exponential equations, we are trying to get the bases to be the same, right, on either side of the equal sign so that we can drop the bases, right? So what is 5 to the 12? 5 to the 12, if I'm to write it in its prime factors, you can use the shift fact on your calculator. So if you press on your calculator 512, right, then you press, wait, hold on, let me check on my one. So you can press 512 and press equals, I think, and then you press a shift at the top, and then fact is, where's fact on here? So you press shift on your calculator and then you look for fact. My fact is above, yeah, it's somewhere on the top button. It's fact, like that, right? That should give you 2 to the power of 9. So this can be written as 2 to the power of 9 is equals to 1 over 2 to the power of n minus 1, right? Now I can bring this up, right? I can bring this 2 to the power of 9 up. It'll just turn into 2 to the power of minus 9. 2 to the power of minus 9 is equals to, and I'm going to bring this 2 up as well. So it'll be 2 to the minus 1 times n minus 1. Okay, if I expand this, I will have 2 to the power of minus 9 is equals to 2 to the power of minus n plus 1, right? Now I can drop the bases because both of these are 2, so this is 2 and this is 2, and so I can make this 2, oh, sorry, I can drop the bases, so it'll be minus 9 is equals to minus n plus 1, and so I can bring I'm going to move the n to that side and move the not minus 9 to that side, so it'll be n is equals to positive 9 plus 1, and so n is equal to 10. So in our case, n is equal to 10. That would be the diameter, that would be the circle, so the 10th circle. So in this case, the 10th circle would give you a diameter of 3 over 128. Okay, so again, like the area one, we had to first find what our diameter pattern was, right? We found it to be 12, then 6, then 3. Then we could find our A, we could find our R, and then we could write out the Tn formula for that, right? And then from that Tn formula, you could substitute in the value that they actually wanted, the Tn that they've given you, to find the N that you want. Okay, cool. And then I think our last question for today, we start off with functions, so we'll continue again. I think it's going to be not, today is Wednesday, Thursday. It's going to be only next week, Monday, is when we're going to do the next one. Please use log. Okay, how can we use log here? We can use log. So if we wanted to use log, we could use it from this point over here, right? We have 1 over 512 is equals to a half to the power of n minus 1. Now, log works as this. Log works like if I have, log works as, how does it work? If I have 3 is equals to 2 to the power of x, 3 is my answer, 2 is my base, and x is my exponent, right? If I want to change this into log form, I would say log of the base answer is in the bracket is equal to the exponent, is equal to the exponent, like that, right? And so here, if I want to change this to be a log, I would say log of 1 over 2, 1 over 5 over 2 is equals to n minus 1. Let me just check this. So log base 1 over 2, and inside that log is 1 over 1, 512. This gives you 9 is equals to n minus 1. And so then you move the 1 to that other side, so it'll be 9 plus 1 is equals to n, which is equal to 10. So you can use log here if you feel more comfortable with log than with exponents. Okay. And so the last question, just starting off with functions, is you're given this function, f of x is equals to is equals to a to the power of x minus 1. And they've given you a point B. They told you B is 2 and minus 5 over 9, which is an x value and a y value. And they want you to find the value of A. How do we find that value of A? Can you guys tell me? How do you find that value of A? We're going to substitute in the point that we have here, right? So we're going to put in y is minus 5 over 9 is equals to a to the x, which is 2 minus 1. And now we're going to just solve for a, right? So we're going to have minus 5 over 9 plus 1 is equals to a squared. So that'll give us 4 over 9 is equals to a squared. Okay, then you're going to square root both sides to get rid of that square root, and you have to add a plus minus whenever you add a square root, right? And so this gives me a positive or negative 2 over 3 is equals to a, but they told us that a is greater than 0, right? So it has to be the positive version. So a is equals to 2 over 3. Okay. Okay. So that was the start of our function questions. If you guys would like to work through some of the questions before our next session, this was the 2024 November paper. 2024 November paper. And so if you want to continue on, we finished on 4.1. So if you want to continue with 4.2 to the rest of it, then you can. And then we'll discuss it and go through it together when we do the next paper, when we have our next lesson. Okay. Does anyone have any questions from before this? Okay, cool. So the recordings of the session will be on our YouTube channel. If you are confused about something that we did before, then you can look on that on the YouTube channel. So it's just at the learning space. and you'll be able to find a recording of this. And we also have a TikTok and an Instagram where we do some questions to help you prepare as we get closer to exams. So, yeah, I hope that you guys had fun and you enjoy the session. I will see you next week, Monday.